So the key way to tell the difference between the different stages of sleep is initially by looking at the EEG. We'll see in the next slide that we also need the EMG, some other factors. But the EEG, the electroencephalogram, this electrical activity of the brain, is the classic means by which we measure stages of sleep. And of course, when we talk about arousal states, we're including waking in there as well. So what we see here are the different EEG patterns of these different arousal states, from waking to non-REM and the 4 stages of non-REM, and to Rem sleep. All right. First thing you got to know about these waves, these are combinations of action potentials. Okay, it's a very gross recording. The good example of what an EEG is you're sitting on the top of a domed sports complex and you're listening to the noise of what's going on inside. You might be able to determine when the home team scores a touchdown or when there's a big play, but it's pretty gross. You're not going to be able to tell the score or many details about it. That's pretty much what an EEG tells you. All right? So EEG is broken down into different waves. And the waves have 2 characteristics. They have a speed and they have an amplitude. Now the speed is also called a frequency, and it's measured in hertz, cycles per second. So if you see if there's a very rapid change, this is called a very fast wave, very fast up and down cycles, as opposed to something like this, slow up and down cycles. So these would be considered fast waves, and these would be considered slow waves. Okay, so the rate at which we cycle from peak to peak is a measurement of frequency. All right, and it tells us a lot about the differences between the EEGs. The other thing we measure is the height or the amplitude of the wave. Is it small, low amplitude, or is it high amplitude? Okay, so in waking, we have very fast, low amplitude waves. You see it? All right. Then as we start to transition into sleep, and we always transition to non-REM initially, non-REM stage 1, this is arguably somewhere between drowsiness and actually falling asleep, you see that the waves slow down a little bit. They're not as fast over here. Okay? And then we transition to stage 2, and there's some particular characteristics in stage 2 that denote that it is stage 2. These sleep spindles are one thing. There's K complexes, stuff like that. Not important for you to know. Scientists who are determining the stages of sleep need to, in order to determine the difference between stage 1 and stage 2. Notice the amplitude is going up a little bit. Waves are still slow with these little fast spikes in there. And then we transition into stage 3 and stage 4 of non-REM sleep. And this is arguably called slow wave sleep, because this is where we see the predominance of slow waves. This is a slow wave, okay? And we see a certain percentage in stage 3 and a greater percentage in stage 4. So you see the difference between stage 1, stage 2, stage 3, and stage 4. And the difference between 3 and 4 is the percentage of slow waves that exist in a recording cycle. All right? It's these slow waves that give you that good restorative sleep that you want. When you want to go to bed at night and get a good restoration, it's the slow waves you're looking for. Okay? This is where you're drooling on the pillow here. This is the deepest sleep you're in. But then look what happens when we transition to REM sleep. REM sleep, it goes right back to fast waves, low amplitude. It looks very much like waking or even stage 1. Okay, so the EEG can tell us a lot about the different arousal states.